We'll start in 1 minute. Today we'll start in Chapter 3 in Section 3.1, Part A. We will look at how to graph linear equations in 2 variables. But first, we'll discuss what a rectangular coordinate system is. A rectangular coordinate system consists of a horizontal number line and a vertical number line. The horizontal number line is the x-axis, and the vertical number line is the y-axis. The x-axis and the y-axis together form the xy plane. So I have a little bit of room here. I'll just illustrate by graphing a horizontal number line, which is called the x-axis, and a vertical number line, which is called the y-axis. So you can label a few points on the horizontal and vertical number line. So this is just a rough sketch, just to give you an idea of what we're going to be looking at in a few minutes. The point where the x-axis intersects the y-axis is called the origin. So this point right here, this is where the x-axis and the y-axis intersect. So that's referred to as the origin. By origin, the word means a starting point or a starting place. The positive x values are on the x-axis to the right of the origin. So I've illustrated that here in this little picture. The positive numbers are to the right of the origin on the x-axis. And the negative x values on the x-axis are to the left. And I labeled those also -1, -2, and so on. The positive y values are on the y-axis above the origin. So on the y-axis above the origin are the positive y values, and the negative y values are on the y-axis below the origin. Okay, and this is referred to as the xy plane. Plane meaning 2 dimensions. You know this statement. Every point in the xy plane corresponds to an ordered pair, x comma y in parentheses. So an ordered pair will always have this form. The variables don't have to be x and y, but x and y are the variables that we use most commonly. Okay, so an ordered pair consists of an x-coordinate and a y-coordinate, and it's conventional that the x-coordinate appear on the left and the y-coordinate appear on the right. The origin is a point in the xy plane, and it is the ordered pair 0, 0. So 0 for x and 0 for y. Another term is quadrant. The xy plane is subdivided into 4 quadrants. Quadrant 1 is the upper right part of the xy plane. And then we move counterclockwise. Quadrant 2 is the upper left part of the xy plane. Quadrant 3 is the lower left part of the xy plane. And quadrant 4 is the lower right part of the xy plane. So I'll draw a little picture here again. So we have the x-axis and the y-axis. The upper right quarter or quadrant is the first quadrant. So that's Roman numeral 1 for the first quadrant. And then counterclockwise, the upper left is the second quadrant. The lower left is the third quadrant. And the lower right is the fourth quadrant. Okay, let's practice plotting some points in the xy plane. So we'll plot 2 or 3 points on in one graph of the xy plane. So the marks that I'm making represent integers. So the positive x values, 1, 2, 3, 4, and 5, and so on. -1, -2, -3, -4, -5. Positive y values, 1, 2, 3, 4. Negative y values are -1, -2, -3, -4. Hey, the ordered pair -5, 4. The x-coordinate is -5. So what we do, we can start from the origin. And if x is -5, we move along the x-axis towards -5. The y-coordinate is +4, so that means we're going to move vertically upwards 4 units. So this point is the ordered pair -5, 4. The next point, -3, -4. Which quadrant is the point -3, -4 in? Which quadrant?
3.
Right, it's in the third quadrant. So -3 for x and -4 for y. So we start at the origin, -3 for x, move to the left along the x-axis to -3. -4 for y means we move downward or in the negative direction. And we'll label this point -3, -4. The ordered pair 0, -1. Oh, where in the xy plane is that point? 0, -1.
It's on the y-axis.
Yeah, it's on the y-axis. It's not actually in a quadrant, but it's on the y-axis. So 0 for x, and then -1 for y. So we have this point, 0, -1. Okay, for the other 2 points, let's draw another x and y axis. We could have used the other one, but we can space these out a little bit more. Okay, the ordered pair 3, 2, from the origin, the x coordinate is 3, so from the origin we move along the x-axis to the right to get to x equals 3. Then y is equal to 2, we move up 2 units. So this is the ordered pair 3, 2, x-axis and y-axis. And then the ordered pair 1, 0. So the x-coordinate is 1, so we move to the right 1 to x equals 1. The y-coordinate is 0, so this point stays on the x-axis. This is the ordered pair 1, 0. A couple of observations. If we go back and look at this point, 0, -1, this point is a point on the y-axis. Notice that the x-coordinate is 0, and that's true for any point on the y-axis. Every point on the y-axis has an x-coordinate of 0. And analogously, if you have a point on the x-axis, no matter what point it is on the x-axis, the y-coordinate is always 0. So it's a little detail, but an important one. Okay, let's move on to the next page. Hey, here's another definition. A linear equation in the variables x and y can be written in the standard form ax plus by equals c, where a, b, and c are constant real numbers, and a and b are not both 0. So we would allow a to be 0, but if a is 0, b cannot be 0, and vice versa. It's possible for b to be 0, but if b is 0, a is not 0. Otherwise, there's no line to consider if you allow both to be 0. C could be 0. Okay, this next sentence, the equation 4x plus 6y equals 12 is a linear equation in the variables x and y in standard form. So for this equation, the value of a is 4, b is 6, and c is 12. And here's another linear equation, y equals -2x plus 7, This equation is not in standard form, but let's write this equation so that it is in standard form. So all we have to do is what? To get this equation into standard form. So we want the y term and the x term on one side of the equation and the constant real number on the opposite side. So how can I get this equation into standard form? Yeah, if we add 2x to both sides, so add 2x to both sides, we get the standard form. Okay, the next definition, a solution to a linear equation, ax plus by equals c, is an ordered pair, x comma y in parentheses. So a note, a linear equation, ax plus by equals c, has infinitely many solutions. So in a minute, we'll find some solutions to this equation, 3x plus 2y equals 6. But let's discuss what it means for an ordered pair to be a solution. What do you suppose it means for an ordered pair of the form x comma y in parentheses? What does it mean for that ordered pair to be a solution to an equation ax plus by equals c? Okay, I'll write down a sentence or two about what it means for an ordered pair to be a solution. Okay, so an ordered pair x comma y in parentheses is a solution to ax plus by equals c if replacing x and y in the equation ax plus by equals c with the x and y coordinates of the ordered pair I'll just refer to the ordered pair as x comma y. If that substitution produces a true equation, well, you may have encountered linear equations before, and if you haven't, and if it's still a little bit murky, then when we start doing examples, it should clear up. Okay, so let's find 10 ordered pair solutions to the equation 3x plus 2y equals 6, and then afterwards we'll plot the ordered pairs in the xy plane. Okay, so one way to go about finding solutions, ordered pair solutions, is just to create a table of x and y values that go together. So there are infinitely many solutions. All we want to do is find 10. So that's not even a drop in the bucket. So any ideas on how to start?
Take a point and substitute it in.
Okay, yeah. For a linear equation and the variables x and y, we can start by picking one of the variables and substituting any number we want into that variable, and then doing the arithmetic to find the value of the other variable. So I'll start out easy. I'll start by picking x to be 0. So if x is 0, I didn't have to pick 0, but I can pick 0, so I pick 0 for x. So in the equation, we have 3 times 0 plus 2y equals 6. We solve this equation for y. So we get 2y equals 6, so y equals 3. So that means the ordered pair 0, 3 is one of the solutions to that equation. Okay, 9 more. Well, I can also pick y to be any number I want. If I pick y to be 0, then I get 3 times x plus 2 times 0 equals 6, or 3x equals 6. And then when we solve this equation for x, we get x equals 2. So we have the ordered pair 2, 0 that is a solution to that equation. Okay, those are the 2 easiest points to find. Well, in my opinion, they're the easiest ones. But if we pick x to be another number besides 0 or 2, how about if I pick x to be -2? So this gives us 3 times -2 plus 2y equals 6. So this means -6 plus 2y equals 6. Add 6 to both sides, we get 2y equals 12. And so y equals 6. So we have the ordered pair -2, 6. Hey, just a few more. So I've been so far I've avoided fractions. You don't have to avoid fractions. You can pick a number for x that results in a fraction for y, or vice versa. Fractions are perfectly fine numbers. We just tend to avoid them if we can. Okay, so I'll give you about a minute or so. Find a different solution than we've found so far to that equation, 3x plus 2y equals 6. So if you find an ordered pair solution online, then type one in parentheses, left parenthesis, a number, a comma, another number, and then a right parenthesis. Did you find one? Since I don't hear too well, if you find one, write it on the chalkboard. So are you stuck?
Could you tell the solution on there?
Put it on that board so I can see. Okay, I have an example in class and also an example online. So the one online has 6 for x and -6 for y, or 6, -6. Well, let's check it. I'll first replace x with 6, 3 times 6, plus 2 times -6. And we want that to be equal to 6. And sure enough, 18 minus 12 equals 6 is true. So this is true. So that verifies that 6, -6 is a solution. The one in class, 4 for x and -3 for y, or the ordered pair 4, -3. So in the equation, 3 times x, we'll write 3 times 4, and then plus 2 times -3. And this is supposed to equal 6. So 12 plus -6 equals 6. That's also true. So the ordered pair 4, -3 is also a solution. Well, rather than finding 5 more, let's just plot these ordered pairs in the xy plane. So I'll try to graph them somewhat accurately. Okay, the first ordered pair, 0, 3. 0, 3 is right here. The next ordered pair, 2, 0, is right here. Then -2, +6 So that point is right here. Then 6, negative 6, 6 for x. So this is a little off scale. So 6, positive 6 for x and negative 6 for y. So I'm almost off the grid. 6, negative 6. And then our next one, 4, negative 3. Okay. So this is a fairly accurate graph. What does it look like those points have in common? Remember the term for this? 3x plus 2y equals 6. What kind of equation is it?
Linear.
It's a linear equation in the variables x and y. Linear equation. So what do you suppose that means graphically?
Not going in straight line.
Yeah, the graph of a linear equation in two variables, x and y, is a straight line in the xy plane. So the term itself helps you remember what the graph looks like. The graph is supposed to be a straight line. So this sort of resembles a straight line. Every point on that, every ordered pair on that line is a solution to the equation. So the line, when we graph the line, that represents infinitely many solutions. Okay, let's move on to the next page. Okay, so here's a statement to reinforce what we just observed. The graph of a linear equation, ax plus by equals c, is a straight line in the xy plane. In order to graph a linear equation, ax plus by equals c in the xy plane, only two distinct points are needed. So you might have taken geometry, and one of the axioms of Euclidean geometry in 2 dimensions is that a single line passes through 2 different points. So in order to graph a straight line, all you need are 2 distinct or 2 different points. So this statement here says the same thing. There exists one line that passes through 2 distinct points in a plane. Okay, here's an equation of a straight line. This is not in standard form, but this is still an equation of a line, a linear equation. It could be written in standard form, but you don't have to write it in standard form. In fact, this is one of the forms that is sort of convenient for graphing linear equations. So let's graph the equation y equals 4x minus 1 by plotting points. So all we need are 2 different ordered pairs. Okay, so how do you want to start? Some advice here. In this equation, since y is expressed in terms of x, it's probably more convenient to pick x to be a number and replace x in that equation with that number that you pick. Do the arithmetic to determine what y is equal to. Do that for two different values of x, and we'll have two different ordered pairs. So you get to pick x to be anything you want. But usually we try to pick something that's easily managed. You know, if I pick x to be 1,242, I could do that, but it's not going to be very nice graphing that. So if we pick numbers that are small and easy to work with, we can easily find two ordered pairs and then graph the line. Okay, what do you want to do? What do you want to start out with for x?
0.
Okay, that's perfectly fine if you want to pick x to be 0. So in the equation, replace x with 0, we get y equals 4 times 0 minus 1, or 0 minus 1, which is negative 1. So we have the ordered pair 0, negative 1. Okay, now what?
-1.
You want to pick x to be negative 1? Okay. Pick x to be negative 1. And over here, we'll do the arithmetic. So y equals 4 times negative 1 minus 1. Negative 4 minus 1 is negative 5. Okay. So the ordered pair negative 1, negative 5 is a point on the graph. Someone online suggests 1, presumably x equals 1. So if x equals 1, the y-coordinate is 4 times 1 minus 1, or 4 minus 1, or 3. So the ordered pair 1, 3. Okay, we have enough. All we need are two different ordered pairs. So 0, negative 1. Negative 1. Negative 1, negative 5. And 1, 3. So those are all points on the same line. My graph is not completely accurate, but it's fairly reasonable for a graph of a straight line. Okay. The next equation, graph y equals negative x divided by 3 minus 3. Graph that straight line by plotting 2 points. So we just want to find two ordered pairs, x comma y in parentheses. If you always want to start by picking x to be 0, there's nothing wrong with that. If I pick x to be 0, the y-coordinate is negative 0 divided by 3 minus 3, or 0 minus 3, which is negative 3. So we get the ordered pair 0, negative 3. Well, we have a fraction involved. This is like negative 1/3 times x minus 3. And there's a strategy that you can use when you see fractions involved. So if we pick x to be a number, then we have to divide it by 3. So if you want to avoid fractions, you can. If I pick x to be a multiple of 3, 3 is a multiple of 3, 6 is a multiple of 3, and so on. Or negative 3 is a multiple of 3. You're not required to pick a multiple of 3, but you can if you want. So let's pick x to be 1, and then find the y-coordinate. Y equals negative 1/3 minus 3. And then we're using improper fractions instead of mixed numbers. So negative 1/3 minus 3 is negative 1/3 minus 9/3, or negative 10/3. So the ordered pair 1, negative 10/3 is a point on the line. But I'm going to find one more ordered pair that doesn't have fractions in the ordered pair. So I'm going to pick x to be 3. And the y-coordinate when x is 3 is negative 3 divided by 3 minus 3, or negative 1 minus 3, which is negative 4. Okay, but we can plot those points. Okay, the point 0, negative 3 is right here. So you'll want to get into the habit of labeling points. The ordered pair of 3, negative 4 is right there. So 1 and negative 10/3, or negative 3 1/3, is about right there. So we get a straight line. Okay. Now let's graph the equation y equals 2. The variable x does not appear, but what that means is x can be any number as long as the y-coordinate is 2. X can be any number as long as the y-coordinate is 2. So I'll pick x to be 1 that has a y-coordinate of 2. So the ordered pair 1, 2 is a point on the graph. I'll pick another x value, like 3, and as long as the y value is 2. So I get 3, 2. So what kind of line is this in the xy plane? Yeah, it is a horizontal line. Okay, so the ordered pair 1, 2, the ordered pair 3, 2. is a horizontal line. Its equation is y equals 2. So that is going to be true in general. In the xy plane, if y equals a number, then the graph is a horizontal line, and every y coordinate of the points is the same number. Okay, let's graph the equation x equals -3 in the xy plane. This time the variable y is missing. What does that mean? Yeah, this time it means y can be any number as long as the x coordinate is -3. So if I pick x to be -3, I can pick y to be any number. So I'll pick y to be 1. So the ordered pair -3, 1 is a point on the graph. And then we need another point. So this time I'll pick x to be 2, or sorry, I'll pick y to be 2. And then x has to be -3 because the equation tells us x has to be -3. So what kind of line do we get on this one? What kind of line?
A vertical one?
Yeah, it's a vertical line. So -3, 1, and -3, 2. The graph is a vertical line. Okay, so that's true in general. If x equals a number, then in the xy plane, every point on the line has to have the same x coordinate of whatever that number is. Okay, let's start the next page. This says determine. So there's a word missing. Determine which of the ordered pairs are solutions to 5x plus 9y equals 4. So this first ordered pair, x is 7 and y is -31/9. So we can test this in the equation 5x plus 9y equals 4. Replace x with 7. Replace y with -31/9. And we want to see if it equals 4. So 5 times 7 is 35. And 9 times -31/9, the 9's cancel. So 5 plus -31 equals 4. That is true. So that means 7, the ordered pair 7, -31/9 is a solution. Okay, you would go do the same sort of thing with the other 3 ordered pairs. Let's test the one on the right. The ordered pair 0, 10. So this time replace x with 0 and replace y with 10. And do we get a true statement or a false statement? So do the arithmetic, we get 0 plus 90 equals 4. Well, that's clearly false. So that means the ordered pair 0, 10 is not a solution. Well, we're about out of time. Tomorrow we'll quickly sketch the graphs of these two equations, and then we'll also move on to Chapter 3, Section 1, Part B. Okay, go ahead and sign in for attendance. Bailey? Carter Hill. Nicholas. Anthony Holt. What's the other job? Hey, let's grab everyone.
Are they here today?